So hello guys and welcome back. So basically, as you might have seen in the thumbnail, we had this question in our thumbnail, and let me tell you, these questions are absolutely crazy, okay? Like highly relevant to JEE Advanced, and this question I really liked this question. So before starting on a little bit of storytelling, because I need to tell who has actually created this question. So basically I was scrolling through Reddit and I on a post I found this question out, and I was like pretty impressed by the way this question is made, and I wanted to find out who has actually made this question. So basically I scrolled a lot through Telegram and I found out a channel whose name is Mathsplorers. I have like this question is not created by me. They have created Mathsplorers, their admin. They have created this question. I have attached their Telegram link in the description as well. You can go there and you will have access to all of them. Okay. And because this is like these questions are really good, so I thought I should bring them up. And so this will be the first question, guys, for today. You can try this question out. This isn't a difficult question, but yeah, you have to like I will be, I guess, doing maybe two sums per question per video. So these questions will take some lot of time. And if you have like, maybe if you are like, this question is purely from calculus. So if you have not yet finished on your calculus syllabus, I would say please don't touch this question. You can turn off the video right now, okay? Or you can go to the next question. That will be a trigonometry one, but please don't touch this question. If you have completed that part of your syllabus, only then touch this, because it will, this question, like all the questions that I will bring on, they will use everything that is taught in that particular chapter, okay? Like crazy, okay, crazy stuff. So this will be the first question, guys, and you can try this out. I will wait for a few seconds as usual and then solve it. Okay, so guys, I guess now it's time for us to start off. So basically you can see that we have two functions f and g which are defined something like this. So I have no space actually in my screen here. So I guess you have well jotted down the question. So now I am going to change the page and start solving this. So what I will do is I will first write down the question itself, which is our f of x equals to your limit of n tends to infinity, and we can put a bracket here, n factorial times x plus n, x plus n by 2, dot 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 till x plus, this will obviously be n by n. We don't cancel this, we write it as n by n only because it will be a progression, as you can understand, okay? So this is whole divided by n power n. Basically you can make some sort of idea only. If you have done enough sums, you will know that this is a question on involving integration as a limit of sum, okay? So now what we will do is, our one more thing was given, let's write that down also. Ln f of x was given to be your integral 0 to x some g of t dt. So basically two functions, g of x and f of x, okay? So now what we will actually do is, let's rewrite f of x into some good form so that we can perform operations. I will write f of x as limit n tends to infinity, and you can observe a pattern in all this bracket and stuff in the numerator. This thing is actually your pi, that is a product, r equals to 1 to n, 1 plus rx by n, and this is the whole part of x by n. This is the actual thing, and I guess it's pretty clear. And now one thing can come to your mind, like we have rx by n and everything here. Where did this n factorial go? So n factorial and n power n can cancel. Guess I don't have to tell that. So this is it. Okay, guys, actually I said something wrong in flow. Basically n factorial and n power n will not get cancelled. Okay, I'm showing that. So what will happen is, actually n power n is your n's multiplied. So from here you put 1 n each to these brackets. First thing, okay, all these brackets. So it will become, I am writing the first two brackets for your reference to show. So it will like become x by n plus 1, and this thing will become x by n plus half, okay? And after that, basically our n factorial, I am writing it somewhere here, N factorial is basically your n into n minus 1 into n minus 2, and this goes on in dot dot 3 2 1. Okay, so we take this 1, multiply it with this, we take this 2, multiply it with this term, 3 we multiply with the third term, 4 we multiply with the fourth term, and with the last term we multiply n. And after doing all this, you will actually see that it is coming to this. Okay, I should have explained that before. Anyways, so that's it. And now what, this is the final form that we have. It was given something sort of complex, but we have resolved it. Okay, so now what we will basically do is, we can't evaluate integral, like you can understand, right? 1 plus rx by n, it's very like, it will sort of lure you to apply integration as limit of sum, and that is very evident and correct also. So to do that, we have to actually convert this pi into sigma, because it's not in a standard form, and for that we'll take ln of x on both sides. So let's take ln, and ln of x will be your limit n tends to infinity, and now this thing will be x by n will come here, and we will have your sigma r equals to 1 to n, and ln of 1 plus rx by n. I guess this is it, yeah. So now we can write this as, now one thing that can confuse here a little bit is that why we have x outside. Okay, this will be adjusted later on, because if you like multiply x inside, you try to take x forcefully inside, it will become x plus rx square by n, and there is no other like way to bring it to this form. Okay, so you can't mingle with this x. What you can rather do is write limit n tends to infinity. Okay, you don't need the limit right now, we are directly like converting it into the integral form. Okay, so what I'm doing is I'm keeping x outside for the time being, and I am taking like, what should I do? I should take r by n, this thing. I am replacing it with the variable y in the integral. Okay, I hope you can understand. So integral 0 to 1 will be the limits, very obvious, and this thing becomes ln of 1 plus xy dy. Okay, this is the like thing we took, dy, and now we have x outside, so we need this completely in terms of a single variable. So what we will do is we will substitute xy as t. So in this integral, x is a constant, which means your, or rather you can substitute, okay, leave, xy will be t. So x dy, because x is a constant here in this integral, it will be equal to dt. So now we can rewrite this expression. I will change the page and rewrite. So this thing becomes your integral, x is gone, 0 and xy equal to t. So this becomes 0 and this becomes x. This will be ln of 1 plus t dt. Okay, so this thing is actually your ln of f of x. So now I guess there is not much of difficulty left over. And what we can actually do is, something was also given to us, like ln of f of x is also equal to integral 0 to x g of t dt. Okay, so if you actually equate these two expressions, you can differentiate both sides, and using L'Hopital's rule, you will have g of x equals to ln of 1 plus x for, and so you have got it. And now as you can see, 1 plus x, so obviously we have to define x in an interval. This is all for x greater than 0 always. Okay, so that's done. And now I guess I will look into the question once more, because we have to solve further. So looking into the question, we actually have another term which is given as alpha equal to limit n tends to infinity pi r equals to 1 to n 1 plus r by n squared. Okay, now what can, okay, I am going to the page and then I will explain that part. I'm going to the page down. So basically our alpha was given as your limit of n tends to infinity pi r equals to 1 to n, and this thing is your 1 plus r by n square. Now what we will first do is, we will obviously take ln, because I don't think there is any other way to proceed. So ln of alpha, this comes out to be your limit n tends to infinity, and this is your pi sorry, not pi now. Now it will be sigma r equals to 1 to n ln of 1 plus r by n squared. Okay. So after this particular step, actually you will have confusion that how are we going to make this as an like integral. Okay. So we are not going to actually do any integration here. What we will rather do is we will take the help of expansions. Our ln of 1 plus x expansion is x plus x square by 2, and it goes on like that. Okay, we don't need these terms, we only need this term because we want to keep it linear because g of x has come linear. That is why I also want to keep alpha linear. So we can write this as limit n tends to infinity. Basically you can say we are performing an approximation, but yes, except that there is no other way out. So in place of x we will substitute r by n square. So this becomes a sigma r equals to 1 to n, and what I will do is I am writing this as r by n and 1 by n outside. Okay, r by n square it was, we wrote it as 1 by n r by n. So basically you can see this was not in the form of an integral, I converted it using approximation into an integral. That was the reason of taking x. Okay, so now I guess we can write ln of alpha as equal to, this will be your I guess integral of 0 to 1, and this is your r by n, so x dx. This thing comes out to be x square by 2, limits 1 to 0, so this is half. So alpha, it comes out to be e power half. Okay, so alpha has come out to be e power half. So I guess now we are ready to go on to our options. So let's check on our options. Okay, so option A, B, C are all of alpha power gx, and some I guess B and C have values and A has something less than, so let's prove it. So alpha power gx will come out to be your e power half, and that is I guess gx was your ln of 1 plus x, which means it will be root 1 plus x, right? So, and this is obviously for x greater than 0. So I guess I don't have to tell this that root 1 plus x is obviously less than your 1 plus x. Okay, so alpha power gx will be less than 1 plus x. So basically option A is I guess correct. And now we will go on to the values putting. I will see what values they have asked. So I guess we have to find out, in one it was given alpha power g8 and in the other it was given to be alpha power g3. So if we find out your alpha power of g8 first, it will be root 8 plus 1 root 9, so 3. So basically this thing, or option B, will be correct. In place of alpha power g3 we have to put your root 1 plus 3, which is root 4, so this will come out to be 2, but it was given as 4, so your option number C is wrong. And now in our final option we have to find this out, I guess g7 by g3. So if we find out your g7 by g3, I guess what we can basically do is, okay, we don't have to manipulate this, like it was a ln 1 plus x, right? So ln 8, and this thing I guess will be ln 4, so 3 ln 2 by 2, I mean 3 ln 2 by 2 ln 2. So this actually came out to be 3 by 2, which means option D is also correct. So our correct options for this question will be A, B and D. This was a fantabulous question. I liked like the question framing and all, they are really good. Okay, I will see if I get more questions like this from them, from their Telegram channel, and I will keep posting that. And really like huge shout out to these guys because they have prepared a great number of interesting questions and really relevant questions. Okay, you can see everything of this is relevant to your JEE Advanced. So if you can solve these questions, you are in really good position. Okay, so anyways guys, I will proceed on to the next question for today. So here's our next question guys, and this is also like beast looking question. Enough beast looking. Anyways, it's not like very difficult, but yeah, the framing of the question is really good. Okay, it's 4 options and 4 questions, and maybe I guess this is one chapter, this is a second chapter, no, not a second chapter, functions. So one chapter, second chapter, Then this is a third chapter, this is a fourth chapter, this is a fifth chapter. So basically 5 chapters in one question. Okay. So you can see, like, crazy. Anyways, you can try this question out and I will wait for a few seconds and then start solving this. Okay guys, I guess now it's time for me to solve. So basically before doing anything we have to solve this huge g of x thing, and it will involve a huge lot of trigonometric manipulation. So let's quickly do that. I will change the page because I have no space here. So first let's write out our pretty huge g of x, which is equal to 4 cosine x, and this thing is your whole divided by a huge thing, which is 3 plus of 12 sine squared x minus of your 2 cosine 2x plus of your 12 sine square x and your cosine 2x plus of 3, I guess it was 3 cosine 4x. I hope I've written this correct. I will check anyways if this 3 was there or not. Yeah, this 3 was there. So I am not writing this whole huge fraction repeatedly. We will take this denominator directly and first manipulate this because this is not looking normal at all. Okay. So let's take this thing, and what I will do is I am going to sort of group. Okay. So let's do one thing. I can see 3 here and 3 here. So let's make this into a pretty 3 times. So 1 plus cosine 4x, and we will take 12 sine square x also common because I can see there is a common. So 1 plus of cosine 2x, and this is your minus 2 cosine 2x. Okay. So 1 plus cos 2 theta is 2 cos square theta. So this will be 6 cos square 2x plus of 12 sine square x, and this thing I guess will become your 2 cosine square x minus of 2 cosine 2x. So what we have here is 6 cosine square 2x plus of, this will be 24 sine square x cosine square x minus 2 cosine 2x. So now from here let's do one thing, because we have cosine 2x sine square x cosine square x as well as cosine 2x. What I am targeting is I am targeting to convert this completely into either sine or tan. Okay. So sine or cos. So let's go for cos. I mean, let's go for sine because a sine is already present. I guess, like, let's see what happens. Okay, I am doing it for sine. So to convert, what I can basically do is I can write this as 6 and cosine square 2x. So you know that I can write this separately. Your this thing, which is cosine 2x, this is 1 minus 2 sine square x, right? So this becomes 1 minus of 2 sine square x whole square plus of 24 sine square x, and this thing is your 1 minus sine square x. Okay, actually this thing is turning out to be pretty fruitful, because from here 4 sine power 4x will come, which will become 24 sine power 4x in plus, and there is a 24 sine power 4x in minus coming from here. Okay, cancellations are occurring, which means we are in the right track. So let's go ahead. This thing will be minus 2 times 1 minus of 2 sine square x yet again. So I'm changing the page, guys. I don't have any space here. So now if we expand this particular thing, this is your 6 times. I will write all these steps, okay, because I don't want to like leave any confusion. 1 minus 4 sine square x, this is plus 4 sine power 4x, and plus 24 sine square x minus of 24 sine power 4x minus 2 plus of 4 sine square x. So 6 times 4 is 24 sine power 4x, which will get cancelled with this. Again, minus 24 sine square x getting cancelled with this. and 6 minus 2 will be 4. So 4 times 1 plus sine square x. This is pretty good, at least better than what we had earlier. Okay, so our g of x, it comes out to be 4 cosine x whole divided by 4 times of 1 plus sine square x, which is your cosine x whole divided by 1 plus sine square x. And now I guess we have our g of x in hand. So let's look into what they have said further in the question. So furthermore in the question, they have given us something here also, which is f of x equal to integral 0 to x g of t dt. So I guess, and after that, most of the questions are actually based on f of x. So we need to manipulate f of x. Let's do that. So your f of x is given out to be integral 0 to x cosine x whole divided by 1 plus sine square x dx. And I guess guys, we don't need to go for any complications because we can actually directly integrate this. This is looking actually very proper. Okay, so if you actually take sine x to be t, your cosine x dx will come out to be dt. So it will become actually dt by 1 plus t square, which is the tan inverse integral. So this thing will actually come out to be, I am not putting like doing all that again. You can understand dt by 1 plus t square is tan inverse t, and then we put on tan inverse in place of t sine x. Okay guys, actually I should not like write this as x also. Replace this variable with some t maybe. Okay, it will be geometrically or mathematically wrong because cosine t by 1 plus sine square t dt is better because x is already in the this part. Okay, anyways, so tan inverse sine x is your f of x. So now we are actually pretty ready to solve anything and everything. So in the first question, I guess, I mean in the first option A, they had given us to find out integral 0 to 1 f of x dx. Okay, this is something that is very much asked in your this thing JEE Advanced. You can recommend PYQs also. This was given to be less than equals to I guess 9 by 20, right? This sort of a question has already come. That's why I was telling these questions are highly relevant. So what we can actually do is, I am writing an inequality integral 0 to 1 f of x dx. Okay, now tan inverse sine x, if we compare tan inverse sine x and tan inverse x, so you will already know that x will be always greater than equal to sine x. Okay, why equal to? Because there is a case of x equal to 0. So what we can say is your tan inverse x will be always greater than or equal to your tan inverse of sine x. I hope this is clear. So actually we can write this as less than or equal to integral 0 to 1 tan inverse of x dx, because we have tan inverse sine x here. Okay, and now I guess you know the expansion for our tan inverse x. If you don't, please remember this because this is very important. X minus x cube by 3 plus of x power 5 by 5, and this goes on till infinity. This much is actually okay for you to remember. This is called Taylor-Maclaurin series, as much as I remember the name, Taylor-Maclaurin series. Okay, so now we can put this and actually find out the values. I am going down, I have no space here. So now an obvious question will come to your mind, that how do we know how many terms we have to actually take in the integral? Okay, we are not going to take the whole expansion obviously. So you can see there was 9 by 20. 20 is some sort of related to 5. So I guess we can take 3 multiples. Okay, that's some sort of, you can like, maybe this is not very logical, but yes, exam hall ideas will work like this. So integral 0 to 1 f of x dx, this will be less than or equal to your integral 0 to 1 x minus x cube by 3 plus x power 5 dx, and this will be less than or equal to, if we evaluate this thing, this is your x squared by 2 minus of x power 4 by 4 plus of I guess x power 6 by 6 other 30 dx. Okay, okay guys, I actually made a mistake. This thing is a x power 4 by 12. Okay, you can ignore this part, I was just doing some rough work. So basically what we can calculate is, this is less than or equal to, I actually calculated that roughly here. So half minus of 1 by 12 plus of 1 by 30. Okay, So this thing is your, I guess, 5 by 12 plus 1 by 30. And if we take the LCM, this will be 12, 5 to 60, 25 plus 2, 27 by 60. Which if we reduce with 3 is actually 9 by 20. Okay, so our assumption was correct. So your integral 0 to 1 f of x dx is actually less than or equal to 9 by 20. So our option number A is 100% correct. Now let's go on to option number B. So in option number B, it basically says that if we take some beta belonging to 0 to pi by 4, then there would be a line y equals to beta, like it would be a horizontal line obviously. It would intersect the curve of f of x like 2n times in the interval 0 to 2n pi. Okay. So if we have to like find out whether this will happen or not, we have to examine the curvature of f of x. So f of x is your tan inverse sin x. Now, if you actually try to observe the curvature of this particular curve, this will be your 0 when x equal to 0. I'm just plotting some values, okay? Let's take after this some value, say x equal to pi by 4 if we take. This will be sin pi by 4 tan inverse 1 by root 2. Okay. Or actually what we can do is leave this thing. What we can actually do is, one thing that you can basically observe is there will be a period, like this function is actually periodic function, okay, and the period will be 2 pi. I guess I don't have to explain this, you have studied your functions well. And if we try to find out the range of this function, -1 to 1, right? So if it is -1 to 1, I guess this will be range minus pi by 4 to pi by 4. Okay. And now if you actually see, say if we observe from 0 to pi by 2, like I am doing all this because little bit of information, because in the exam hall you won't have any those online graph drawing tools and also you can't see whether the curvature is looking like this. You have to find it out, okay? So 0 to pi by 2, actually sin x, it increases from 0 to 1. You all know that, right? So y equals to our this thing tan inverse sin x, whatever it is, it will actually increase from 0 to pi by 4. Now if you observe from pi by 2 to pi, our sin x, it decreases from your 1 to 0. So y equal to our function will again, I'm sorry, decrease from pi by 4 back to 0. So 0, like it is 0 to pi by 4, again pi by 4 to 0. And if you actually check the others also, you will find that this is like this, okay? So some sort of actually a sine curvature is itself coming. So I guess the curve of this particular thing will be something like this. It is actually like very much resembling the sine curve itself. This much information was enough to prove that. This thing is your like this, okay? And if you want to actually know this point, this will be pi by 4 and this will be your minus pi by 4. This is your f of x equals to tan inverse sin x, okay? And now I guess our question said that between any 0 to 2n pi, y equals to beta belonging to 0 to pi by 4 will cut it 2n times. So let's take any arbitrary beta. And let's also, like, we don't need the negative part anyways, we need the positive part only. So 0 to 2n pi. Okay, so the intersections will be at pi, 2 pi. So what we will do is, let's take n equals to 1 for the rhyming. We had 2n pi, right? So let's take n equal to 1. So till n equal to 1, you will observe the curve goes like this and two intersections. So yeah, again if you go like 2 pi to 4 pi, like this is 2 pi, this will be 3 pi, this will be 4 pi. Again if you go, you extend till 4 pi, again there will be two intersections. So basically this option is actually also correct, okay? There will be two n pi intersections in 0 to 2n pi. for y equals to beta, provided this condition is satisfied. So B is actually correct. Okay, this is the correct option again. So now let's go on to the next option, number C. So guys, in our option number C, it basically says that limit h is tending to 0, your f of h minus of f of 0 divided by your h power alpha, this has to exist. Okay, so you can see this is actually the first principle. Okay, definition of first principle. So this will only exist when alpha is equal to 1. This can only exist when alpha is equal to 1 and there is no other way. Okay, because if denominator becomes greater than the numerator, this will become invalid completely. So I guess our option C was also correct. Okay, I will anyways check the statement once for option number C. So option number C basically says that there exists an alpha belongs to natural number such that limit h tends to 0, this thing is existing and it is finite. Yeah, alpha is obviously belonging to natural number. So till now A, B and C have come to be correct. Let's look at the next option, which is option number D. So option number D basically said that we have to prove f is an increasing function in between 3 pi by 2 to 5 pi by 2, which is pretty simple. What we can do is we can go back to our old that trigonometric manipulation we did, find out f dash x, which was equal to g of x, that we found as cosine x by 1 plus sine square x. So in our said and known interval 3 pi by 2 to 5 pi by 2, this particular thing, like if we put 3 pi by 2 say, so cosine 3 pi by 2, okay, so which means pi minus pi by 2, so it is I guess pi minus pi by 2, so it is a negative quantity, and 5 pi by 2 is 2 pi minus pi by 2, so it's a positive quantity. So negative quantity towards positive quantity, which means it is an increasing function. So in this particular like thing, if we checked at the two endpoints, you can take two intermediate points also and check. I basically did at the endpoints because that's pretty simple. So g of x is actually coming to be greater than 0 in this interval. So basically f dash x is increasing in your 3 pi by 2 to 5 pi by 2. So I guess our option D is also correct. So pretty universal question. A, B, C, D, all options are correct for this question. Okay. So guys, this will be the last question for today. We have come to the end for 2 questions. So I will bring more questions in the next video, don't worry. And if you have liked my content, please do like, share and subscribe, because it takes a lot of, you can see this, it takes a lot of hard work to solve this stuff. Okay, so please do like, share and subscribe if you can, and any doubts please drop me in the comment section. And one more thing, I found out some of you were asking me questions in the comment section, so rather than doing that, go to my description, you will find my telegram, go to my telegram and message me there, then I can easily communicate with you. Okay, so that's it for today guys, and thanks for watching.